radical functions. Okay, and yesterday, if a rational function is called proper if the degree of p is smaller than q, is improper if the degree of p is larger or equal to q. Okay, and the first case in the denominator if they are the product of linear functions. Okay, we know that we can somehow rewrite these radical functions as the sums of these terms. Look at this. Each of them, the denominator is a linear function. On top of that are the constants. Our job is to determine the correct constant so that they are the same. Okay? There are many ways. I explained to you the way I normally do. Imagine there's a number 1 right here, but you can follow the Weber-Science technique. So just multiply both sides with the denominator q. It will cancel some terms, and finally at some point it will give you like the equation 4 here. Okay, the equation 4 is nothing else but we just take the equation 3 here, we multiply both sides with this denominator. Okay, and we have an equation. Our job is to determine A, B, and C. So it is true for all variable x. The trick is that, so we can pick some specific values of x so that we can solve for A, B, and C very fast. So we can choose any numbers, but the clever way is to pick the solution of these linear terms. For example, here, we pick the solution of the term x here, which is x is equal to 0. When we substitute this value when x is equal to 0 to the equation 4, it is clear that b and c, the term here, will disappear so that we can solve for a easily. Okay. Similarly, if we pick the solution of the term x plus 2 is equal to 0 here, in other words, we pick x is 2x minus 1, we pick x is 1/2. Substitute that value to the equation 4, then a will disappear because a times 0 will be 0. The c will disappear so that we can solve for b easily. Similarly, we can pick the solution of x plus 2 equal to 0, which means x is equal to -2. It will cancel the terms of this. So, in other words, we can find the value of c. Having all these values, the integral, the rational functions here becomes the sums of simpler functions. Okay? Then we can solve these integral easily. That is the whole idea of this section. Okay? So now your job is to memorize. It's like a map. If you know the maps, you can point, you know the target, you can find the fastest way to go to the target. Okay? Although you know that there may have many paths to lead to the solution. But if you know the general idea, you memorize all these, you can do it faster. Yesterday, we've done the first case, right? When the denominator q is a product of linear functions. The second case we will cover will be in the denominator q here, the linear terms, the linear equations, for example, a1x plus b will be repeated. It means it will be raised to the power of r, for example. Okay. So what should we do in this case? And it is proven that we can write this rational function in terms of this sum is in the equation 7. Okay. So memorize it. Okay. look, the denominator is a linear function. The numerator is 1 degree lower, which is a constant, right? Very special. And here, it will be the sum of the first order, and then the square of these, and then raised to the r, okay? This third case, if in the denominator has a irreducible quadratic factors, the quadratic functions, we call it irreducible when there's no solution. Or the discriminant d, b squared minus 4ac, is smaller than 0. Okay? In other words, we cannot write it in terms of a product of two linear functions. In that case, then we can write the rational function is like this term. It will be added, this term in the equation 9. Look at this. The denominator is the quadratic function, and the numerator is 1 degree lower, which is a linear. Okay? The highest degree here is x squared. The highest degree here is x. And in this situation, we need to determine two variables, a and b. Okay? So the similar idea, in the fourth case, if this irreducible quadratic factor is repeated, it is raised to the power of r, what should we do? Okay? It is proven that we can write it as a sum of these. The denominator of this irreducible quadratic factor, and then the second terms will be that raised to the power of 2, etc. until this to the r. Each of the numerator here is linear terms, 1 order lower than the denominator. Okay. Now, spend a minute of your life. Memorize all the ideas here. 4 cases. Okay, ready to go? Continue? So, if you don't remember it right now, go back home, take a look at the notes I gave you, study these. It's like memorizing a map. Now you have a map, you know where to go, right? What to do. Very well. And a reminder that sometimes if the polynomial is irreducible, is improper, the rational factor is improper. In this case, what should we do? Improper means the degree of P is larger than the degree of Q, right? Very good. Thank you, correct. So we do long division. Okay? And how to do long division? Go back to what we've done. So yesterday, the video is uploaded already, or review it yourself somewhere. You can find it easily in Google, okay? And a very important trick here. If a function f of x is ax squared, plus bx plus c, and given that the discriminant is b squared minus 4ac, if d is smaller than 0, then what is it? Irreducible, right? Maybe the spelling is not good. Okay, check it yourself. How about if d is smaller than 0, larger or equal to 0, then it will has at least one solution, right? Then we can write f of x is a. So there are two solutions. Let me write it here. So we have the solution will be x1, x2 will be minus. And we can always write this. This one? The solutions. X1 or X2, the two solutions. Or do you mean?
Is that like x1 comma 2?
Yeah, X1, or you can write it this way. X1 would be this, and X2. Okay. Mathematicians are lazy. We want to write something quick and fast that we understand. That's it. Okay. So there are two solutions, X1 or X2 here. Then we can always write this quadratic function is the product of a times x minus x1 x minus x2. Okay? The trick is this. Sometimes we find the solution here takes a little time, right? If you do factor many times, you know that, you know the trick. So in order to find these two, yeah, we just consider the product of A and C here. Product of A and C. So let us, okay. The trick is that we can separate Bx to be Ax plus Bx. We can always write it this way so that we can factor them out. And the beautiful thing is that the capital A and capital B here, the sum of them, A plus B, will be, yeah, actually the small b here, right? Yeah, the secret is their multiplication is A times C, right? Okay. Okay. Double check it. Okay. Now let us go back to the example yesterday to double check it. Okay. Let us see if it works or not. Here, yesterday, this one, we have this, right? Let us copy it. Here. Okay. We know that this guy is equal to this guy, right? Let us delete this guy. Okay. So look at this. According to the trick here, a of this quadratic function is 2. C is -2, right? So 2 times -2 will be, what is it? -4, right? -4 is 4 times, what is it? -1. And we see that 4 plus -1 is, what is it? 3, which is exactly this term here. Okay, so this is the trick. Therefore, from this, we know that we should write this 3x terms is 4x minus x, right? You agree? The reason we decompose it into 2 terms is this, the trick here. Then, what should we do? We factor, right? If we factor the first 2 terms, what do we have? Louder? Just factor 2x, because it is the like term of these 2, right? And what is left inside? X plus 2, right? How about this guy? If we, thank you, very good. It is x plus 2 again, right? Okay, so is it clear up to this point? Okay, so now, what should we do next? What is the like term between these 2? Yeah, x plus 2. This implies that we know we should factor x plus 2 out, right? So it will be, the inside will be? Okay, this is the way how we can factor these things, okay? The second way, we can use the formula or this trick. Just memorize these, you can do it faster. Are we good? Very well. Then, let us continue. Okay, now we go into details of the second case when the denominator is the linear terms is repeated r times. So look at this example 3. The denominator here looks complicated. Okay? When they give the problems, they tend to give a beautiful things. We know that somehow we don't want to give an ugly numbers, right? So typically with these, the solution you can check first. You check, try if the solution of the denominator we try if plus or minus 3, plus or minus 2, plus or minus 1, or 0, if any of them is a solution of this. The beauty of this is For example, let us try if 0 is a solution of the denominator. Is 0 a solution? No, when we replace the value of 0, this one, the first term here will be 0, 0, 0 plus 1. It's not equal to 0, so 0 is not a solution of this guy. Okay? How about 1? Is it a solution of this? Let's try. If x is equal to 1, then x cubed minus x squared minus x plus 1 becomes 1 cubed minus 1 squared minus 1 plus 1. What is it? One cube will be 1, right? 1 square is 1. Negative 1 plus 1, it is equal to 0. If x is equal to 1, then this is a solution. Therefore, we know.
Wait, wouldn't that 1 squared become positive?
Be careful.
Oh, you're right.
Yeah, be careful. Very good. Thank you, Alu. So, and is a good question with Jonathan or Alex? Okay, thank you. Just be careful with the negative sign. Okay. If this is a solution, then it is a very beautiful properties that x cubed minus x squared minus x plus 1, we can write it as the product of x minus the solution here, which is 1. And some things here. We can always do this. We can only write it as a factor of x minus a solution multiplied with something. The question is, what is this guy? What is this question mark here? How can we find it? Very good. Let us do the long division, right? It can be written as a product of these two. So it means when we do long division, the remainder should be 0. Very good. Let us do the long division. Okay. So in long division, we want to divide x cubed minus x squared minus x plus 1 by the denominator. In this case will be x minus 1. Okay, very good. So what should we do? Take the highest degree of this guy divided by the highest degree of this guy. What do we have? Yes, x squared. Very good. Then, what should we do? Yes, multiply back here. And x squared multiply x will be x cubed. X squared multiply negative 1. Negative x squared. Then, what should we do? Very good. Remember, we will subtract the whole things here. Okay. X cubed minus x cubed here give us? Very good. Thank you, Alex. The second term? Also 0. Negative x squared. Subtract negative x squared will be 0. And the remainder here will be? Very good. Okay. So continue doing this. We take the highest degree of this guy, which is negative x, divided by x. What do we have here? Negative 1. Okay, good job. -1 here. Then again, -1 multiplied back to this divider, right? It will be -x plus 1. Very good. Okay. Then again, we subtract these two guys, right? What is it? Yeah, a very beautiful 0. Okay, it means, okay, the remainder is 0. It means that this guy divided by x minus 1 will be x squared minus 1. And therefore, this guy will be x squared minus 1. Okay? Are we good? Very well. Good job. So, continue. This guy, look at here. They have done this for us already. And it's beautiful right here, right? Wait a second. Okay, well, we do not follow this instruction. Let us write it this way. We know that this integral becomes x to the 4th minus 2x squared plus 4x plus 1. And the denominator, we just found it. It is x minus 1 times x squared minus 1, right? We just done how to factor this quadratic terms, okay? But their way is more elegant. They do long division at the beginning because this is improper. So when we do long division, the similar story we've done, and it becomes this guy plus this guy, okay? That's nothing different. We can do our ways, okay? Anyway, the remainder of the long division. Yeah, it's fine. We can do our ways, okay? But anyway, if we do it this way, let us follow their instruction here. The similar story. This guy here, look at this. The denominator is x minus 1 squared plus a times x plus 1, right? And the strategy tells us that, okay, we can write this as a over x minus 1 here plus b over x minus 1 squared plus c over x plus 1. Okay? Is it clear? Do you have any question? I cannot hear you clearly. Louder, please. Oh, 4x is the remainders of the long division. The long division of this. Okay? You can do the similar things here. What I have done here, the long division here, is to guide you how to factor the denominator. Okay? You can do their ways here. Okay, now we do long division. And just focus on this guy. Okay. Focus on this. Sorry. So yeah, their way will be faster. They do long division first, and this is irreducible. I mean, this is proper irrational function here is proper, so we can write it in this way. So let us follow their strategy here. It's better, I believe. But anyway, so let us, okay, focus on this guy. We want to write this guy in terms of this. Okay? Then let us follow the WebAssign instruction. If we multiply both sides by the denominator, what do we have? The left-hand side will be? Yeah, the left-hand side is 4x. The right-hand side will be a multiply with the whole denominator here, x minus 1 squared times x plus 1, right? Divided by the same things. Oh yeah, plus b, sorry. B over x minus 1 squared times this guy plus c over x plus 1 sorry. We multiply with the denominator here. Then we simplify it, right? In this way, x minus 1 squared, it is x minus 1 times x minus 1, right? So we cancel one of them. With one of them here. So what is left here? First term. Very good. Okay. Good job. Continue. The second terms. X. Very good. And the last terms here. Very good. Okay. Is it clear up to this point? Good job. Continue. Okay. X minus 1 times x plus 1, it will be? Good. Or, yeah, let us follow the trick here. Okay. Just look at this. We want to find A, B, and C, right? This equation is true for all x. Okay? Therefore, it will true for some specific values of x. So let us consider some specific values. Okay, what should we choose these values? Very good. At x is equal to 1. Therefore, we have the relation here. 4 times 1 will be the right-hand side. At 1, this term will be 0. This term, 0. Therefore, the left-hand side becomes, be careful, x is equal to 1, okay? 1 plus 1 give us 2b. Good job. So what is b? Very good. 4 is 2b, therefore b will be 2. Good job. is a lot faster, right? So we pick another value to find A and C, right? Which number should we choose here? -1, okay. The left-hand side, when x is equal to -1, it will be very good. The right-hand side becomes if -1, this term would be 0, right? Disappear. This one would be 0, disappear. And this one would be C times. Good job. It would be? Yeah, 4C is -4, then C should be -1. Great. Does it make sense? Perfect. Okay, so what we need to find more is A, right? Yeah, you found B and C already. You can replace the value and multiply, and you find find A easily, right? But another way, because we know B and C, or we can also pick a random value, right? Somehow it makes our computation easier. Okay? Which number should we choose? It's up to you. Okay, at 0 is smart choice. Because when we replace 0 here, the left-hand side becomes 0, and the right-hand side is A times 0 minus 1 times 0 plus 1 plus. Very good. And C. Okay, good. Do we know B and C? Yes. So A times this one would be -1. It would be A times -1. And B here times 1 will be 2. And C here is -1 times -1 squared, right? -1 squared give us 1 here. So it would be minus A plus 2 minus 1 equal to 0. Then what is A? Good job. Okay. We found A, B, and C. Therefore, this implies that, okay, we can write this guy oops. We can write integral of this guy. Let us write it this way. Integral of x to the 4th minus 2x squared plus 4x plus 1 divided by x cubed minus x squared minus x plus 1 dx. We can write it as integral of x plus 1 dx here. And this term becomes, let me see, A divided by x minus 1, and A here is 1, right? Here, B divided by x minus 1 squared. We copy these faster. oops. Oh yeah. B x minus 1 square and b is what is it? 2. Okay. Okay. Good job. So does it make sense? C is -1. Oh yeah, yeah, -1. Yeah. Good job. Thank you. Oh, here, yeah, here's plus. Very good. Right. Oh, no, no, no. Yeah, yeah, I see. Just copy and we got a mistake. Okay, anyway. Is it clear? Then solving each of them is easy. Okay? I believe that you can do it at home. Okay? Go home, finish these problems, and double check if you find a similar result. Let me write down the result here. Okay. First, guys, here is x squared with 2 plus x plus this guy would be natural log of, what is it? Very good. Plus, here this guy you can do, yeah, find out how to solve it. It is natural log of x minus 1 over x plus 1, okay? And this, the last one is negative natural log of this is x plus 1 plus a number where c is in R, okay? Double check it. Okay? In order to solve this guy, because we don't have time to solve it in details, but do you have any idea how to solve it? Any suggestion? Do substitution. Yeah. If we substitute u to be x minus 1, this becomes 1 over u squared. And yeah, or just go home, do it. I believe you can do it well. And I think tomorrow we will be studying this section, okay? Continue with this. And do the test review. The test will be similar to what we're doing here in the test review. Okay, yeah, have a good one.